So we're going to go through some more examples. So we have the first one. Write the probability of the event that is complementary to each event. So the first one says the probability of choosing a jack from a pack of cards is 1 on 13. So we're going to do this words exactly the same. We're going to do the opposite of choosing a jack and then change the probability. So we're going to say the probability of not choosing a jack from a pack of cards is, now if you choose the jack it's 1 over 13, so not choosing the jack will be 12 over 13. Okay, so we've got 13 things all together. Getting the jack is 1, not having it is 12. So those numbers on the top, these ones, have to add up to the 13 on the bottom. Okay, now the next one. The chance of shooting a basketball hoop is 61%. So we're going to do the opposite of that. So this is shooting a basketball hoop. We're going to do the opposite. The probability of not shooting a basketball hoop is, and we want the opposite of 61%. Now with the percentages, we know that 100% is 1 hole. So if you get a whole test right, you get 100%. So we're going to take off 61% off that, and if you work that out, you get 39. So 39% is the opposite. Okay, looking at the next one, this time it says the probability of winning a prize is 0.15. We're going to say, the complementary event, the probability of not winning a prize is, now to get our answer here, we're going to do 1 whole, take away the 0.15 that they gave us, and that will give you 0.85. Okay? Same back at this first question here. You could have done this one here by doing 1 take away 1 over 13. So most of the time you're going to do 1 take away the fraction, 1 take away the decimal, but in the percentages it's 100% take away the percentage. Okay, so they're a bit tricky, but when you practice them, you'll get better at those. Alright, now this question is a really tricky one, so it is hard. You can write hard near this one, because there's a bit to think about, and it is really badly done when we give these in tests. So if we have a bag of toy cars, there are only 3 colours, red, blue and white. If you take a car out at random, the chance of it being red is 0.4. Chance, remember, is probability. So they're telling you the probability that it's going to be red is 0.4. And the probability of it being white is 0.25. They have not told you how many cars there are. They haven't told you how many red cars. They haven't told you how many blue cars or how many white cars. They've only told you 2 probabilities. So let's see what they're asking. What is the chance, or what is the probability of selecting red or white? Now, the word or always tells you to add. Okay, it's really helpful to know that. So if we want a red or a white car, we're going to add the probabilities of the red car and the white car. And that will give you the probability of getting red or white. So it's 0.65. Now up here, the probability of getting a blue car. Now remember, there were only 3 colours in the bag. There was red, blue and white. We've already got the probability of a red or a white. So all that's left is blue. So we're going to take 1 and subtract the chance of getting the reds or whites, and that will leave us with the chance or probability that you're going to get a blue car. The next one, what is the chance of selecting a pink car? Now, there are no pink cars. They told you there are only red, white and blue cars. So that's been thrown in to confuse you. The probability of getting a pink car is 0. It's impossible. All right, the second part of the question. Now they're going to tell you, if the bag holds 40 cards, how many of each colour would you expect to find? So this is one of those expected ones. So remember, with the expected questions, expected number, you're going to do probability times the number of trials. In this case, the probability times the number of cars, the total number of cars. Okay, so we're finding how many red cars there are. So we're going to have a look back here. The probability of having a red car is 0.4. So we're going to do 0.4 times the 40 cars. And if you work that out on your calculator, you'll get 16. So we have 16 red cars in the bag. For the white, the probability of a white car was 0.25. So for the white cars, we're going to get that probability of white times by the 40 cars, and you get 10 white cars. Now to find the blue cars, we did find the probability of blue up here. That's why you've got to label your work as you're doing it so you can find what you need. So up here is the probability of getting a blue car, 0.35. So we're going to do that probability times 40, and you get 14 cars. Now, that question also could have been done by going, well, once I've done the red and the white, I've got 40 cars in the bag, take off the number of reds, take off the number of white cars, and you should be left with the number of blue cars. So these both give you the same answer. You can choose which way you want to do it. Okay, one more question. So this one here, in a family, there are mum and dad, 2 daughters and a son. So we've got mum, dad, 2 daughters and a son. 5 people. Each day, they take it in turns to wash the dishes after dinner. If you visit the family, what is the chance that the person washing up is male? Well, let's see how many males we've got. Dad is a male, and we have a son. So there's 2 males in the family. So the chance of having a male washing up will be 2 out of the 5 people in the family. What's the chance that we have not a parent doing it? That means it's a child. So we have 2 daughters and a son. There's 3 children in this family. So we've got 3 out of the 5 people. C, what's the chance that it's not mum washing up? Well, the only people that are not mum are everybody except mum. So there's 4 people in the family out of 5 that are not mum. And the last one, what's the chance that that person is not male? In other words, what's the chance the person is female? Mum is a female, and so is the daughter. There's 2 daughters, so mum and 2 daughters, 3 females in the family out of 5. Okay, so now all you've got to do is practice this work.